This sample problem will cover mortar mix design as well as masonry calculations for Plan 100. Standard Plan 100 has a concrete foundation, but we are going to replace it with a masonry foundation for the second portion. But starting off, we're going to look at our mortar mix design sample calculation. We are given some densities, our unit weights for both masonry cement and Portland cement, as well as our lime and our sand. We'll need these when we're calculating our volume and converting it into our weight. Make sure when you're doing your calculations that you read through the entire sample problem. It will provide information in different sections that you'll need back when you start the problem, so make sure you look at the whole thing. We're starting off with just 1 and 2 as one mix design, and then we'll look again at 3, 4, and 5 as our second mix design. But starting off, we're only going to read through this portion and then make sure you refer back to it as we list out our 1 and 2 steps. So we are going to create a mixture that has both masonry cement and sand, where the volume of sand is 3 times the volume of masonry cement. So we want to calculate the volume and weight in cubic feet and in pounds required to mix a 12 cubic foot batch of type N mortar. So starting off, we need to figure out what our individual parts are so that we can then find out what our total parts are for a mix design. So we always base everything off of our cement, whether it's our masonry cement or our Portland cement. We always start off with 1 part cement. Everything is based off of this, so just 1 is our starting point. Sand, we were told, is 3 times the value of our masonry cement. So to calculate that, it's just 3 times our 1 part, and we have 3 parts for our sand. So total parts, simply adding it all together. The total is our 1 part of cement plus our 3 parts for our sand. We have 4 total parts. If you think about it in relation to baking or some other ingredient-based function, you can always double it or halve it or 1.5 times, whatever it is, if you have your base ingredients. That's what we're calculating here. So if we have a multiple of 4, it's pretty easy to figure out what our calculations are going to be for each of the individual parts, but it doesn't have to be. It can always change. So from this, we can then figure out what our cement is. So our first blank is the cement cubic foot. To find this, we need our 12 cubic foot sample size that we're looking for, or our batch size, and we divide that by our total parts that we just calculated. Nice multiple of 4, so we know we have 3 cubic feet of masonry cement that we're going to be using in this mixture. The unit weights can easily tell us then what our pounds of masonry cement are going to be. The units we see are listed as PCF. That's read as pounds per cubic foot. Another way of writing that is pounds divided by cubic feet. Either way is acceptable, but it makes it easy to cancel out our cubic feet and be left with pounds as our answer. So if we multiply that out, we get 206.4 pounds for our weight. Now whether you write LB, LBS, write out pounds, there's different way of writing it. Either are acceptable for this problem. So number 1, when we're looking at our masonry cement, we have written in that we have 1 part. That's already given to us. We have 3 cubic feet, and we have 206.4 pounds that we will be needing to make our batch. From this, we can then calculate our sand. Once we have our cement determined, we don't need to look back at what our batch size is. We can move on and only use this volume of our cement. So if we're looking at our sand, we want to bring down what we just calculated as our volume for our masonry cement, and we multiply that by our parts that are required for sand. So this we already determined. We had 3 parts of sand, so we multiply by 3. That means we have 9 cubic feet of sand required for this batch. 9 cubic feet times the density given, 110 pounds per cubic foot, gives us 990 pounds for our sand. So if we're looking at number 2, as it is written out, we have 3 parts, we have 9 cubic feet, and we have 990 pounds. Now, an easy way to check our answers to make sure that we didn't do any errors, if we're looking for a 12 cubic foot batch size, our unit weights, or our volume, sorry, should add up to that batch size. So if we have 3 cubic feet of cement and 9 cubic feet of our sand, they should total our batch size. If they do not, we know we've made an error somewhere. So that is our first mixed design problem. Next up, we are looking at another mixed design where we have added hydrated lime to the mix. We've replaced masonry cement with Portland cement, and we are also including lime with our sand. So we have a mix of Portland cement, hydrated lime, and sand. Our volume of lime, ranges from 0.5 to 1.25 the volume of Portland cement. So we have a range, 0.5, 1.25. Which one are we going to use? Are we going to use something in between? Well, this is where it's very important that you read through the entire problem. If we come down to our hydrated lime, it tells us that we use the median value of the range. So we're going to find the average and use that as our determination to figure out the number of parts of hydrated lime. Lastly, the volume of sand this time is 3 times the combined volume of Portland cement and lime. So it's not just 3 times the volume of cement, it's Portland cement and lime. Multiply that by 3. Again, we're going to try and find a 12 cubic foot sample or batch size. We start off with 1 part of Portland cement. We're going to find the parts for every ingredient as well as the volume and the weight for each one. So again, we're looking for our total parts. Our Portland cement is going to be our 1 part. Our lime, as it told us, we needed to use the median value. So if our range is 0.5 to 1.25, if we divide that by 2 to find the average, we see that it is 0.875. If we multiply that value times our 1 part of cement, we have 0.875 parts for our lime. Next, our sand. Again, like before, it's 3 times, but it is 3 times the combined value of our cement and our lime. So if we have 1 part of cement, 0.875 parts of lime, that is what we multiply by 3. And we get 5.625 parts for our sand. So total, again, we need to figure out what our value of is before we can calculate volume of cement. We have 1 part of cement, 0.875 parts of lime, and 5.625 parts of sand for a total of 7.5 parts. This isn't a line item that we have to fill in anywhere, but we do need it before we can move on. So looking at our cement, we want to find our volume. Remember, we take our cubic foot batch size and we divide it by the number of parts. So our total gives us 1.6 cubic feet of our Portland cement. Changing that into a weight, we have 94 pounds per cubic foot. We're using Portland cement, not masonry cement, so our density has changed. 150.4 pounds. So if we're looking at the answers for number 3, it is our 1 part of our masonry cement, our 1.6 cubic feet volume, and 150.4 pounds for our weight. And again, now that we have our volume for our cement, we base the rest of our calculations off of this volume, and we don't look back at what our batch size is. So now if we're looking at our lime, our next component, we have 1.6 cubic feet from our masonry cement. We have 0.875 parts for our lime in comparison to our cement. 1.4 is our volume for lime. Our unit weight, 40 pounds per cubic foot, gives us 56 pounds. So filling in our blanks for number 4, our 0.875 parts, our 1.4 cubic feet, and our 56 pounds for our weight. The last ingredient that we are looking at is our sand. Again, we start off with the 1.6 cubic foot, that is our cement. Multiply that by the 5.625 parts that we found for sand, and we get 9 cubic feet. 9 cubic feet times our density, 110 pounds per cubic foot, we have 990 pounds, similar to our first problem. If we want to do our check, we're looking for a 12 cubic foot sample. From that, it needs to equal the 1.6 cubic feet of masonry cement, the 1.4 cubic feet of lime, and the 9 cubic feet of sand. As long as that equals each other, we have done our math correctly, and we are good. Posted on Blackboard is the step-by-step instruction for our mortar mix design. If you ever are confused or need a reference back, this is available for your reference. So we start off looking at the individual parts, always basing with a cement part 1 or 1 part 4 cement, and everything else is based off of that. Again, make sure you read all the directions and specifications carefully so you know if there is a range, what portion of that range you're going to use in your calculations. And once you figured out each of the individual parts, total it up to find the total parts required. This is needed before you can calculate your volume of cement. To do that, you take your sample size or your batch size and divide it by the total parts. This will give you the volume in cubic feet. You can then apply a weight factor to determine the volume in weight that you're going to need for your cement. You can then calculate your remaining ingredients, however many there are, based off of your cement cubic footage. You cannot do any other calculations until you have that cement cubic footage. Once you have that, you apply the individual parts to that cement cubic foot or your volume, and then once you have those answers, you can apply your weight factors to get your answer in pounds or whatever the factor is. Finally, you can check your math, sum up your individual cubic foot for each ingredient to make sure that it actually matches the desired sample size or batch size that you're intending to make, and as long as those sides equal, then you are good to go. So that concludes how to calculate mortar mix design giving 2 different problem samples.